All right, y'all. So the test two material starts out with 7.1, and this is a short section dealing with symmetry. And we'll be looking at three types of symmetry today. So the first one is what we call symmetric to the y-axis. All right, y'all, let me let something in real quick. All right, y'all, so symmetric to the y-axis. So this is when the y-axis cuts a graph in half. So the graph is cut in half by the y-axis. So another way you check it, you can fold the graph over the y-axis and the graph lands on itself. And so it's almost like a mirror image. You're folding it over the y-axis, it lands on itself, so that makes it symmetric to the y-axis. Now, if a graph is symmetric to the y-axis, we say this is an even function. And what that usually means is that the largest exponent of the function is an even number, okay? So I'll draw a little example of a graph that is symmetric to the y-axis will be those parabolas we've been drawing. So if I took the right side of my graph and folded it over the y-axis, this right side would land right on top of that left side, okay? All right, so we got symmetric to the y-axis. We also got symmetric to the x-axis. And this would be the same thing as this. The graph is cut in half. By the x-axis. So that means if you fold the graph over the x-axis, it'll land on itself. Okay, so folding it over the x-axis, it'll land on itself. Now, if you notice, the y-axis, those were even functions. But if it's symmetric to the x-axis, it's not even a function basically because of the two y values for each x. So I'll give you an example of symmetric to the x-axis. But the ones symmetric to the x-axis, like I said, they're not functions because they violate the vertical line test. We often have a graph shooting out like this. So if I took my graph and folded it along the x-axis, the top part lands on the bottom part here, okay? And then, like I said, this ain't a function, y'all, because remember, it fails those vertical line tests. Now, this third one is actually a function. And this one is called symmetric to the origin. And y'all remember, the origin of a graph is the center of the graph. Okay, that's where 0, 0 is located at. That's what we're talking about when we're talking about the origin. So this one you check differently. If turning the graph upside down 180 degrees, and we get the same picture. Or how about, and we get the same graph. Okay, so I'm going to take the graph and I'm going to turn the page 180 degrees. If I got the same graph, then it's symmetric to the origin. Now, if it's symmetric to the origin, we call these an odd function. And what that means is, to be symmetric to the origin, the largest exponent must be an odd number, okay? All right, y'all, so to be symmetric to the origin, I can have a graph come down. It passes through the origin, and then it continues down. All right, so look at this graph, how it looks. It's coming downhill, left to right. Okay? Now watch this. Y'all got the graph here, right? So now I'm going to turn it 180 degrees. And y'all look, I got the same graph. It's coming down on the left, passes through the center, and goes downhill on the right side. So this graph has the same shape when I turn it upside down as it does when it's original graph, okay? So this is symmetric to the origin, symmetric to the x-axis, and then the top one, symmetric to the y-axis. So for these examples, I'm just going to draw graphs and we're going to determine whether it's symmetric to one of these three, okay? So y'all let me start on these examples. So the first three want us to determine if the graph is symmetric with respect to x-axis, y-axis, and or the origin. All right, y'all, so let me try to draw this first one they got. All right, y'all, so on the right side, this one sort of makes a hump and then comes down. on this side, it makes the hump and then comes up. So I'm looking at this graph. I need to figure out which one is it symmetric to. Well, y'all notice this. It's not the y-axis, because if I take the right side and fold it over, this top part right here is going to hit up here. It's not going to land on itself. So it's not symmetric to the y-axis. So then I check the x-axis by folding it over that x-axis. But y'all, when I fold it over the x-axis, this part hits right here. So it's not hitting itself. So the other choice I can look at is the origin. So let's look at how it looks. It's coming down, goes up to a peak and comes down. If I turn it upside down, it's coming down, makes a valley, comes up, makes the peak, and then comes down. The shape of our graph is the same in both pictures when I turn it 180. So y'all, this one is symmetric to the origin. All right, y'all, so number 2. And y'all, I'm going to open up my chat so that if y'all want to figure this one out, I'll let y'all figure it out. So this one sort of comes down on the right, and then comes down on that left. So y'all chat me an answer. What do y'all think this one's symmetric to? Is it symmetric to the Y? Is it symmetric to the X? Or is it symmetric to the origin?
X.
All right, so here's the X. Remember the X, you're taking the graph and folding it over the X-axis, okay? So if we fold this graph over the X-axis, look, this top part's going to hit down here. So it's not hitting itself. So it's not the X. So how about another one? So y'all watch this. How about the Y-axis? If you take the right side of this graph and fold it over the Y-axis, this right side is going to land exactly on that left side, right? Actually, and if you notice, that Y-axis is cutting this graph straight in half. Okay? So y'all, what I'm talking about, if you take that graph and you fold it over, that top part's going to land right on that bottom part, okay? So since the Y-axis is cutting it in half, this one is symmetric to the Y-axis. So y'all, really on the X and Y axis, you're looking for those lines to cut it in half. For the origin, you're looking for the same picture when you turn it upside down. All right, also, how about this one? All right, y'all, so this one's symmetric to the origin, the Y-axis, or the X-axis. All right, so let me see what y'all are putting in here. All right, y'all, so let's see. So I'm getting some origin, some X-axis. So let's check the origin first. Y'all see how this graph looks? If I turn this upside down, it's got to look the same. It's got to be pointing in the same direction. So y'all ready? Oh, y'all, when I turn it upside down, it's going the opposite direction. So remember the origin, it has to look the same both directions. So let's try the x-axis next. So to be symmetric to the x-axis, I got to take this graph and fold it over the x-axis. Oh, good job, y'all, because if you do that, if you fold it over to x, this top part is landing right on that bottom part, okay? Also, if you notice this x-axis here, it's cutting that graph right in half. So good job, y'all. This one is definitely the x-axis. Oh, y'all, the last two questions in that section want us to determine if the function is even, odd, or neither. Now, what you got to remember here, if it's an even function, even functions are symmetric to the y-axis. If it's an odd function, odd functions are symmetric to the origin. All right, y'all, so my number 4. Okay, so this graph is coming over, goes down, and then over here comes over, goes down. So, even or odd, so we got to see, is it symmetric to the y-axis? Well, y'all, if I take that graph, fold it over the y-axis, this side lands on this side, so it's definitely symmetric to the y-axis. To be odd, I would have to turn it upside down and get the same picture. Well, if I turn this upside down, I'm not going to have a N shape. I'll have a U shape, so it's not the odd. So y'all, this one, since it's symmetric to the y-axis, this one is even. Also, check this out. How many times does it touch the x-axis? It touches once here, it touches once there, so that's 2 times. So an even function will touch the x-axis an even number of times, okay? Y'all, this one's sort of tricky to draw. I'm gonna make my x-axis just a little longer. All right, so that was tricky to draw for me. But y'all, I would check my y-axis. Well, if I take the graph and fold it over, this part here is hitting up here. So it's not landing on itself, so it's not a y-axis. And really, this don't look the same on both sides of that y. So now I'm gonna check the origin and see if it's an odd function. So remember, it's going uphill, left to right. When I flip it, 180 degrees, it's going uphill, left to right. So I've got the same exact picture both ways when I turn the graph upside down. So since turning it upside down made it symmetric to the origin, this is a odd function. But y'all watch this. How many times does this one touch the x-axis? It touches it once, twice, 3 times, 4 times, 5 times. It touches the x-axis 5 times, which is a odd number, okay? So even functions touch even times, odd number. All right, y'all. So that was basically 7-1, just learning a little bit about symmetry there, okay? All right, y'all. Then we're going to get into 7-2. So 7-2, we're going to learn about, I got 6 basic graphs we're going to draw. And we're going to be able to take these graphs and move them up, down, left, right, and we're going to reflect them. So those moves are what we call transformations. So y'all, we're going to learn 6 basic graphs real quick. So in this section, these basic graphs are going to be the starting graphs that we're moving, okay? So y'all, the first basic graph looks like a line going right through the center. So let me try to draw this. So the first graph that's basic is a line graph, and this is y equals x. Now, we graph lines like 2x plus 3 and all that, but they all originated from the y equals x graph, okay? So this is basically your line graph. All right, y'all, the second basic graph are the parabolas we've been drawing. So those are the U-shaped graphs. So these are our parabolas. And we got those when we did the x squared graphs. Hey, and y'all did that in 2.1 when y'all drew the x squared plus 3 and all that fun stuff. So the x squared graphs were the U shapes. All right, y'all, next. This graph we drew the other day, they sort of come up, pass through the origin, and then go uphill. So these were the cubes. Y equals x to the third. This is the one where we had to get 4 points to graph in 2.1, okay? And we had to use the squiggly line. All right, y'all, this one starts in the origin here and slowly goes uphill to the right. But it's sort of curving as you go, okay? It's just a slow uphill graph. This is your square root of x. So square root graphs start in the center and they slowly go uphill to the right. The reason the square roots are not on this side is because you can't take the square root of a negative number in the real world, okay? So the square root graphs will start at the origin and sort of head to the right. Now, y'all, this next one is sort of similar to this. Might be a little less tall, but this next one can go in the negative side. So this one will go both directions. This one is a cube root of x. And y'all, you can take cube roots of negative numbers, so that's why this one will go to the negative side, okay? All right, y'all, this next one on the left side, it sort of goes along the x-axis, and then it shoots down along that y-axis. On this side, it comes from up top by the y-axis, comes down, and then it sort of follows the x-axis there. So it don't cross over the x-axis or the y-axis. This one is y equals 1 over x. So we call this the reciprocal. But y'all, the reason it can't cross over this y-axis here, because remember what happens if you put a 0 in for that x? That makes this undefined, okay? So a graph can't cross an x value that makes it undefined. That's why y'all been doing that domain stuff all week. Now, there's one more I'm going to give you. They don't really hit you with on these homework problems here. But since we've been graphing this stuff, I wanted y'all to see this basic graph. So we had one we graphed in the first section that made a V shape. This graph is y equals the absolute value of x. Now, I want y'all to realize these are what we call the basic graphs. The x squared, the x cubed. Now, notice how they all start in the origin, basically. They're all starting in the center of our graphs. So these are the graphs that we're going to learn how to move up and down, left and right, and we're going to learn how to reflect them, okay? So y'all, these will be the transformations that we're going to do. So y'all, the first thing we're going to do a vertical shift. So vertical shift is up or down. So to move one of those basic graphs up, we got to have something in this form. Y equals f of x plus b. So we're taking the function. So if my function was x squared, this would be y equals x squared plus a number, okay? So y'all, what happens? If this b is positive, so if we take our function and add a number to the end of it, it's going to move that graph up. So this moves the graph up. All right, what if this is a negative number? I'm subtracting from the function. If you subtract a number from the function, it's going to move the graph down. Okay, so that's my first move. So an example of this, if I had y equals x to the third plus 4. So if I had x to the third plus 4, the basic graph this starts with, the basic graph it's starting with is y equals x to the third. So y'all, since you see that exponent 3 there, that means it's going to be my cube function, okay? So the function's got to start out with one of these, okay? Now, the plus 4, well, we said right here, if that b is positive, so that 4 is positive, so this moves up 4 units, okay? So that's all you're looking for. Am I adding to it or am I subtracting to it? How about this one? Y equals x squared. So let's do a x squared minus 7. So the basic graph is going to be the x squared because you see an x squared in the function here. So the basic graph will be y equals x squared. So what did this subtracting 7 do to my graph? Well, we said right here, if that number's negative, that's going to move the graph down. So this one moves down 7 units. So y'all, these were my vertical shift. I take the function, add or subtract a number from it. It's either going to move it up or down, okay? So I can move them up or down. Y'all, I can also move them left or right. So to move left or right, we're looking at a horizontal shift. So left and right's coming from your horizontal shift. So y'all, those will look like this. Y equals f of x plus a. Now y'all notice the difference on this. Up here, you had a function and you added or subtracted from it. Down here, the number is going to be inside parentheses with the variable, okay? So y'all look at this. Number is inside of parentheses with the variable. Okay, these numbers up here on these first two examples, they're not in parentheses. But if the number is in parentheses with the variable, that's moving us left or right. If A is positive, now y'all, this is where this one's a little different. Because if you add a number to the x inside the parentheses, If it's positive, it's going to move left. It's going to move graph left. So adding to the variable inside parentheses moves me left. If the A is negative, so if I subtract a number from the variable, that's going to move me to the right. All right, so let me show you a couple examples of this and show you the difference. So I'll do the x cube again. This is so you see the difference. So y'all, this time I got y equals x plus 2 cubed. Now I want y'all to see the difference up here. Up here, I just did the x cube and added 4 to it. Down here, we're adding 2 to the x before it even gets cubed. So it's inside parentheses with the variable. So notice the difference on these. So right here, we're going to start with the basic graph. Well, it's still the cube. So that's going to be y equals x to the third. Since this 2 is positive inside parentheses, we said if it's positive, it's going to move me left. So this moves left 2 units. Okay. And then let's do one subtracting. How about y equals, oh, and I'll do the x squared again. How about x minus 3 squared? So the basic graph, you see an exponent of 2, so that's going to be the x squared graph. So my basic graph, y equals x squared. So it's got to match one of those graphs we drew the first pictures of, okay? Now this time the 3 is negative, and we said if it's negative, it'll move my graph to the right. So this moves right 3 units. So we got to look how they start out, figure out the basic graph, and then what's the moves happening to them, okay? All right, y'all, so the last move is our reflection over the x-axis. Now, we won't be reflecting over the y-axis in this section, okay? But we will learn that later on in life. So right now, the only axis we're flipping over is the x-axis. So y'all, that'll look like this. Y equals negative f of x. We put a negative in front of the function. If I put a negative in front of the function, that's going to reflect it over the y-axis. So y'all, let me mess with that cube again. What if I have y equals negative x cubed? So I see the exponent of 3, so that means my basic graph would be y equals x cubed. So that's the basic graph you're starting with. And then that negative in the front of the function, well, we got a negative in front of our function. That means it reflects over x-axis. Okay, y'all, so reflecting over the x-axis only, okay? So y'all, let me pull up MathLab because these are sort of tricky to graph at first. So while y'all are copying that, I'm going to pull up MathLab. All right, I'm almost there. So many links just to get places. Oh, this is what, 7-2, okay. Almost there. I'm in MathLab now, so I'm just going to wait and try to get to the assignment. All right, y'all, so I got it pulled up, so let me go back to my share screen. All right, y'all, so if you notice, they give me my function. I got to tell it what basic graph we're starting with, and then which one of these moves did it do. So, y'all, let me write this one down on my paper. So number one is y equals parentheses x minus 2 squared. All right, y'all, let me say I had a chat message. Oh, y'all are so close, but guess what? This one has that exponent of 2 on it. So remember, if you see that exponent of 2, when you match it to your basic graph, since you got an exponent of 2, you're going to match that with the x squared graph, okay? So y'all, let me go to my paper real quick. All right, y'all, so on this one, let's see what the... Okay, no problem. All right, so on this one, my basic graph, oh, y'all, I think I got them on this side. The basic graph's got to be one of these 7, okay? Now, what's leading me on is I see an exponent of 2, and if you look at these basic graphs, the only one with the exponent of 2 is your x squared graph, okay? So my basic graph will be y equals x squared. Now notice this. This one is using parentheses. Well, who's using parentheses up here? No, that's the horizontal shift right here. Now this is being minus 2. So when it's got parentheses, we said if that number is negative, it's going to move my graph right. So that means this is going to go right 2 units, okay? So that's basically what we got to put in MathLab to start, and then we graph it, okay? So y'all, let's share our screen and go to the MathLab now. So ours went right to, so you got to find, let's see, A, B, C, looks like D. So you got to get the one that had to the right. And then here for the y equals, that's where we put our basic graph, which was the x squared graph. So we're starting with the basic graph of y squared. We're shifting it 2 units to the right. So y'all, make sure you check the answer. Then it's going to let us graph it. So I'm going to click to enlarge my graph. So the x squared, we know what that graph looked like because we had 7 different pictures of graphs, but the x squared graphs were the U-shaped. And y'all look at it, when you hover over the U-shaped tool up here, it says x squared tool. So watch this. You click the tool and then you click anywhere on the graph. It always starts the graph out in the middle. So it draws the basic graph. What we got to do is use these boxes here to move it to the right. So remember, we went 2 units to the right, so that was horizontal. Now y'all watch that graph as I move this to the right. I moved it right twice. Look at my graph. It was starting in the origin and it moved over 2 places to the right. So y'all let me watch this. I'm gonna move it back. See, this moves it right or left anywhere you want on there, okay? So I'm just gonna go back to 2. So I've moved it 2. That's the only move we had on this one. Save it and then check your answer. All right, y'all, let me see what number 2 is asking here. So number 2, I got g of x equals x minus 6. And now y'all notice that minus 6 is not inside parentheses. So let me go to my pad. So we have x minus 6. That's not inside parentheses. So it's got to be this move right here. Now, that's just the x minus 6, but y'all look over here. My very first basic graph is the x graph. So since that's the x minus 6, it has to be this one it started with. So my basic graph will be the y equals x. Now, what's that minus 6 doing? Well, y'all over here, these numbers are not in parentheses up here. So that'd be something like this. So we had an x minus 6. So since we were subtracting 6, it's going to move my graph down. So this is going to move down 6 units. Okay, so you got to look at it. Are you in parentheses or are you not? In parentheses is left or right. Not in parentheses is up or down. So y'all, let's go move that. We started with an X and we're going to go, what did we say? Down 6. All right, so you come over here. The one that says down 6 is B. And I started with the basic graph, y equals x. Now, since this one is the line tool, when you click to enlarge the graph, notice you get the line tool. On the line tool, you physically got to plot 2 points on this one, okay? So we got an x minus 6. If I put a 0 in for x, I get negative 6. So my first point is going to be 0, negative 6. All right, y'all, so let me think of another point. What if I put a 1 in for the x? So my second x is going to have a value of 1. So if you put a 1 in for the x, you get 1 minus 6, which is negative 5. So when x is 1, y is a negative 5. Now, y'all, you see that line right there? Watch this. We got a calculator. You can go to y equals and put in, what was it, x minus 6. Hit graph. There you go. That's the same exact line we had. And if you need 2 points to plot, hit second graph and use the table. Okay, you can plot any of these x values you want to, 2 of them to get that line, okay? So y'all, if you don't like having to do the table and get your own y values, just plug it in the calculator and let it help. All right, so y'all, there it is, the same line. So I'm just going to hit save. And then you're going to check your answer. All right, y'all, so one more and then we'll do our break. How about that? So this one has h of x equals 1 over x minus 6. Now look, they're telling you you're starting with the basic graph f of x equals 1 over x. So y'all, here's the question of the day. You're subtracting 6 from that function. It's not in parentheses. That 6 is just being subtracted at the end of the function. So would y'all pick A, B, C, or D? Are you going to go down, up, right, or left? And y'all remember, here's your 2 notes that you need on that. Vertical, the numbers are added or subtracted at the end. Horizontal, they're added or subtracted inside parentheses. Well, that 6 ain't in parentheses, so it's got to be a vertical. And since my number is negative, it's going to move me down. All right, so we just got to pick out the one that said move down, okay? So which one's down? A, okay. So A said shift it down. Now this one, they're not going to make us graph. We're going to have to pick the graph. So the question is, A, B, or C, which one went down? Now we'll say this, B is the basic graph. Then that's the one that started at the origin. So it's either A or C, y'all. So let's see. Looks like A went up. So the only graph that went down would be C for us, okay? Because remember, B is down, we drew it, the basic graph. All right, y'all, so I'm going to pause this for a second. All right, y'all, so notice on this one, the 5 is inside parentheses, so that's going to be horizontal. And then I got a negative in the front. Remember, the negatives are going to reflect this over the x-axis. All right, so let's look. It's going to be our x cubed graph because we got the exponent 3 sitting there. And when we subtract 5 from inside the parentheses, that's going to move me right 5 units. And then that negative in the very front is going to reflect us over the x-axis. So we need to find which one went right 5 units and reflected on the x-axis. So that'll be B on this one. Okay, because remember, the 5 is negative inside parentheses, moves it right. The negative in front reflects it over the x-axis. Now, my basic graph we're starting with is going to be x to the third. So that matches the basic graph that we had of the 7 we drew, okay? All right, so you see the 2 moves you started with, and you're going to check them answers. And y'all, that says okay. So now it wants us to graph it. So we're going to click. So remember, the x cubed graphs were the squiggly lines. And if you hover over the squiggly line, it says the x squared tool. So click that. And then you're going to click anywhere on the graph. It always starts them in the center here. All right, so we said we went right 5 units. So take the horizontal, move it right 5. Now I moved it right 5. Now the negative in front reflected us over the x-axis. So down here where it says reflect over x-axis, click that box and it flips the graph upside down. So watch the graph. See, the graph was going uphill. When I reflect it, it's going downhill. All right, so I'll save that, and then you're going to check your answer. All right, so this one got 2 moves. I know it's the basic graph is going to be the x squared graph because I got an exponent 2 there. So you're going to put x and then square that. And then it says shift it blank 2 units. Well, the 2 is inside those parentheses. Since the 2 is inside parentheses, it's going to go left or right. So since that 2 is positive, it's going to go left 2 units. So we're going to come down here and choose left. And then shift it blank 4 units. Well, the 4 is at the end. So the 4 is not in the parentheses. So when it was at the end, it's going to go up or down. And we said if it's positive, it's going to go up. So y'all, I'm just using them charts with the horizontal and the vertical moves and those 7 basic graphs to get my starting picture, okay? All right, so now you had to graph it. So we know the x squared graphs were the U shape. So click on that tool, click anywhere on the graph. It's going to start it in the center. We said we went left 2 units. So horizontal, I'm going to move the -2. That's moving me left. And then we said we're going to go up 4. So take the vertical and go up 4. And it moved my graph up. So y'all, that was only 2 moves. So we save that. Check our answer. So y'all, let me write this one down. This is a good one here. This number 6. F of x equals the square root x plus 9. All right, so I'm going to share my paper with you real quick. So the first thing, the basic graph is going to be y equals the square root of x. Okay. Now, here's the thing about square roots. When it's under the square root, you're treating it like it's in parentheses, okay? If it's under the square root, it's like it's in parentheses. So this is going to be horizontal move, okay? So under radicals are in parentheses, and we said when the number was in parentheses, if it's being added, that's going to move me left 9 units. So we're starting with the square root of x, and by adding 9 under the radical, it moves it left 9 units. All right, y'all, so I'm going to go find MathLab. And they're even telling you you're starting with the square root of x, but then we had to shift it. We said left, and then we went 9 units. Okay. Now this one will have 4 pictures. Remember, the basic graph started right in the center for the square roots. So y'all, here's my square root graph. Remember, they start right in the center. So in those 4 pictures, we got to find which one went up, down, left, or right. And let's see, we said ours went left 9. So it's going to take this picture and move it left 9 units, okay? So let's see which one in MathLab went left. So y'all, A went up. Oh, look at B. B looks like it went left. C went down and D went right. So y'all, we got no choice but to pick B on that one, okay? All right, y'all, look at this. They're telling us we're starting with a cube root of X graph, and they're adding 3. Now notice the difference. This is number 7, so G of X equals a cube root of X plus 3. All right, so let's play with this one. Cube root of X plus 3. Do you see this 3 is not under the radical? See, this 9 was under the radical. Well, this 3 is not under the radical. So what that means, we're taking our number and we're adding it to the end. And since the number's not in parentheses, this one's going to go up 3. Okay? Now, if they'd have made that longer and put the plus 3 under the radical, then we'd have been doing the left and right stuff. But the number's at the end like this, not in parentheses, up 3. And then they told us we're starting with our cube root graph. And remember, y'all, the cube root graph was this one that sort of curved and then curved to the right, okay? So if ours is going to go up 3, it's going to have to be moved up here somehow, okay? So let's go look at Math Lab. So first of all, we said we're going 3 up. So that would be D on this one. And then let's see. A looks like the basic graph. B, that looks like it went down. So if I zoom it in, see that went down. So let me zoom C in. And y'all look at C, that whole graph went up. So we would pick C on that one and then check our answer. But y'all watch this. If you want to know what the graph looks like for sure, we got a calculator, right? So go to y equals, clear this stuff off. We had a cube root. So to get a cube root, you hit the math button and you see number 4. That is a cube root. So then put an X under that, arrow out, and put in a plus 3. Okay, so go to math button to get them cube roots and fun stuff like that, okay? So watch this, watch my graph. See how everything went up on that? And we did pick the right graphs. So y'all, that's what's nice about the calculator. You can graph any of these and get your moves, okay? Alrighty, so this one wants us just to tell what moves it did. We don't have to graph it. So we're starting with that x minus 2. Now we're starting with an x squared graph. So the first move they're doing is it going right 2, left 7, right 7, or left 2? Well, the 7 is not in play. So I'm looking at that 2. The 2 is being subtracted. So when the 2 was being subtracted inside parentheses, it's going to move it right 2. And then it says reflected across. Well, all that negative in front does the reflection. And there's only one axis we're reflecting across in this chapter, and that's the x-axis. So you cannot put y-axis on any of these answers because we're not reflecting anything over the y-axis, okay? And then at the end, that's a positive 7. So that positive 7 is going to move me up 7. So remember, numbers in parentheses, left or right. Numbers at the end, up or down. You know, that's all we did on that. We check our answer and we're done with that, okay? So 7-2, basically, you're starting with those basic graphs. And then you're using those transformations to move them up and down and left and right, okay? All right, y'all, let me look at one thing real quick. All right, so before we do the 7.4, we're going to look at support for 7.4. Hey, this had a few things you need to know in order to do good in the next section. So y'all, I'm going to share my screen and we're going to look at their problems. So number one says solve t squared minus 7t minus 8 equals 0. All righty. So at the moment, the only way that we got to solve this is by factoring. So do y'all remember how to factor? Oh, that's okay, Darren. All right, y'all. So factoring, y'all remember how to factor? So factor is undoing stuff that got foiled together, okay? So who needs a factoring review? Okay, y'all. So before we play with this, we're going to review factoring. So y'all, y'all remember foiling this kind of stuff? We foiled this in section 2.4 when we did the multiplying. So we're going to foil this. This would be x times x, which is x squared. X times 3 would be 3x. 2 times x would be 2x. And then 2 times 3 would be 6. And then let's add like terms, and we get an x squared plus 5x plus 6. So we done that in section 2.4. We foiled this stuff. Well, y'all, factoring is starting with this x squared plus 5x plus 6. Factoring starts with this, and you try to get back to the foiling look. Okay? So factoring undoes foiling. So y'all, here's the first thing. If we have so we're going to be foiling this kind of stuff. So if the last number is positive, then both factors have the same sign as the middle number. The factors will add to equal the middle number. Okay? So if the last number is positive, that's this C right here, y'all. If this C is positive, that means when you write both your factors out, both the factors will have the same sign as the middle number, which is plus on this one, okay? So those two cases would be this. If the last sign's positive, both of these factors are positive like the middle number B here, okay? Now, if the last number's positive, both of these factors will have the same sign as the middle number, which is negative. So the way you get two negatives is when the last number's positive and the middle number's negative, okay? Now the second case, if the last number is negative. So we're subtracting C now instead of adding it. If this last number is negative, then the factors have unlike signs. So one will be positive, one will be negative. So the factors have unlike signs. And the factors subtract to get the middle number. Okay, so the last one was positive, my factors added to get the middle number. If the last number is negative, those factors are going to subtract to get the middle number. Now, here's the thing. The larger factor of the two numbers has the same sign as the middle number. Okay? So your factors are going to subtract to get the middle number. One's going to be positive, one's going to be negative. The larger of those two numbers will have the same sign as your middle number B, okay? All right, so those could look like this. X squared plus BX minus C. Notice my last number is negative now. So that'll give me a plus factor and a negative factor. This will be the larger factor. Since the middle's positive, my larger factor will be positive in this case, okay? And then there's x squared minus bx minus c. All right, the last one's negative, so they're both going to have unlike signs again. But y'all, this time you got unlike signs, but this time, since the middle's negative, the larger factor will be negative. Okay? All right, so that's basically my foiling steps I'm going to follow, okay? So as I foil, I look and see what case do I have. Is my last number negative or is my last number positive, okay? So let's look at our example here. Oh, this one's negative at the end. So that means I'm going to start my two parentheses. Now in the front, you got a t squared. Well, the only thing you can multiply to make a t squared is a t times a t. Okay? Now, y'all, here we go. The last number is this -8. So let me write that. Last number. The last number is a -8. Well, y'all, that comes down to these cases. I have a negative here, and then the other one you can't see was a negative also, but it's negative in the middle. Well, look at my problem. My problem's negative in the middle. Okay? So I'm going with that bottom case that I had, which meant one of these factors is positive, one of those is negative. No matter what, if this last number is negative, you got to have unlike signs, okay? All right, so I'm looking at that last number. Now to finish this, remember, when it was negative at the end, I'm going to find factors that subtract to get the middle number. So y'all find factors of 8 that subtract to get 7. So what factors of 8 subtract to get 7? Well, y'all, let's write the factors of 8. 1 times 8, 2 times 4. Which one of those will subtract and get you a 7? That's going to be the 8 and 1, right? So I got the two numbers. They subtract to give me 7. But remember down here, when we had a negative in the middle and a negative at the end, we said the larger factor would be negative. So the larger factor has to be negative like the middle. So y'all, that means the 8 is negative and the 1 is positive. So if you add 1 and -8, if you add those, you get -7. If you multiply 1 times -8, you get -8. So y'all, that's factored in. So now let's continue on because we got an equation we're solving. So since we're solving an equation, once you got it factored, we now set both of these factors equal to 0. And y'all, the reason I can do that is because of the zero product rule. If you got an answer of 0, then that means either this factor or this factor equals 0, right? All right, so we'll solve these. So here, I'm going to subtract 1. I get t equals a -1. Here, I'm going to add 8. And I get t equals a +8. So y'all, when your equation starts out with an exponent of 2, you're going to get 2 answers. So the exponent always tells me how many answers I get. So y'all, on that one, MathLab will say the solution is, and we put in our -1 and our 8. So let's go throw that one in real quick. All right, y'all, so we got a -1, and then you do comma 8, and then you got to check your answer. Now, y'all, let me show y'all another trick. We got a powerful calculator in front of us. Let me show y'all a trick. If you're weak at factoring, this will help. So y'all remember my answers were -1 and 8. So y'all, let me just graph this function here, but I got to use x's instead of t's. So for t squared, I'm going to do x squared minus 7x minus 8. Now I don't put the equals 0 part. I'm just going to graph this little function they gave me, the t squared minus 7t minus 8. You just got to use X's on the calculator. But y'all watch this. I'm going to graph it. Look where it's crossing this x-axis at. So here's 0 in the middle. Oh, if you go left 1, that's -1. So that graph crossed the x-axis at -1. And on the right side, 1, 2, 3, 4, 5, 6, 7, 8. It's crossing that side at 8. So if you're weak at factoring, you can solve them by graphing them and looking for the x-intercepts. Watch this when I go to the table. Well, look what that y value is at -1 here. The y value is 0. And then remember, I'm going to go down the other way now and look at that other one. Look at the value for here for 8. You got a y value of 0. Remember, these equations were set to 0, weren't they? So if you can graph the function and find the x-intercepts where it's crossing the x-axis, that gives you your factoring also, okay? Oh, y'all, let me go to Math Lab. So we put that one in. We got to see what they got next. All right, y'all, so let me write this one down. This one I sort of solve a different way. So I got a 4x squared minus 12 equals 0. So y'all, I'm just going to write a few of these down and then show you how I would solve them. And there's only, what, 5 of them? And they're starting to look repetitious. So let me see this one. X squared plus 9. All righty, so I'm just going to work these on the pad real quick and not worry about the answers on Math Lab, okay? So y'all notice the difference on these equations in the one while go. While go, I had an x squared, an x, and a number. These, all you got is x squareds and numbers on them. All of these have just an x squared and a number. So we're going to look at a different way of solving these kind of equations. On these equations, I solve them by doing what we call square roots. So y'all, let me show you how that goes. So we're going to try to get the x squared term by itself on one side. So I'm going to add 12 to both sides. So notice that's going to give me my 4x squared equals a positive 12. Now, what you want to do now is make that a 1x squared. So you're going to divide both sides by 4. So y'all, that 4 cancel, you get your x squared. And then 12 divided by 4 will give you 3. So now, what can I do to turn an x squared into an x? Well, we're going to use what we call the square root property. So we're going to take square roots of both sides. So I'm going to do the square root of x squared will equal the square root of 3. Now, here's the thing. When you do a square root of a number, you got to put a plus or minus in front of it. Okay? So y'all, the square root of the x squared, that square root cancels with that exponent, leaving an x. Now, we can't take the square root of 3 because that'll give us a never-ending decimal. So my final answer will be a plus or minus square root of 3. So are y'all familiar with the plus or minus stuff? So let me show you why I'm using a plus or minus. Go on, I'll just start out with a basic number. What is the square root of 4? And I'm going to tell you there's two of them, okay? So give me a square root of 4.
Two.
What is the other
Two.
square root of 4?
2.
Oh, you got my 2 already. And that's because what? 2 times 2 equals 4. So that's a good one. But y'all, I will tell you, there's another number I can multiply times itself and make a 4. How about this? What's -2 times -2 equal?
4.
It equals 4, right? So that means the square root of 4 can be a +2 or it can be a -2. So since the square root of 4 can be a 2 or a -2, I can write that as a plus or -2, okay? So when y'all see that plus or minus, it just means both answers, okay? Now, although I couldn't take the square root of the 3, I still got to use the plus or minus, okay? Because the square root of 3 times square root of 3 will give you a 3. A negative square root of 3 times a negative square root of 3 will give you 3. So both of them will work in the answers. All right, y'all, look at this. 2x squared equals 26. X squared's over here by itself, so we're going to start out by dividing by 2. So that cancels. I get my x squared. 26 divided by 2 is 13. Next, square root both sides. You're doing a number over here, so you're going to use your plus or minus. And y'all look here, the exponent cancels the radical, leaving my x equals a plus or minus. And y'all, we can't simplify that square root of 13. So that's just going to stay a plus or minus square root of 13. All right, y'all. Same thing's happening on all these if you watch. But watch this answer now. So we're going to learn a new thing here. So to solve that, I'm going to subtract 28 from both sides. We get our 4x squared equals that -28. We're going to divide by 4 now. So, that cancels. I got my x squared. That's going to equal -28 divided by 4, which is a -7. So, y'all, watch this. I'm going to do the square root now. So this will equal a plus or minus square root of -7. So y'all got practice. Let me give y'all a little refresher on these negative numbers here. So what is the square root of -4? Well, y'all, that's not 2 because
2.
we said 2 times 2 was 4.
So is it negative?
No.
And see, a negative can't be here because a negative times a negative is a positive, right? So like signs are always positive. So the only way we can't get a negative number from like signs. So y'all watch this. Since we can't take the square root of a -4 in the real world, so remember, can't take square roots in real world. So we can't take square roots of negative numbers in the real world. So watch what we do. Mr. Newton or one of them, they said, hey, let the square root of -1 equal I. So they said if the square root of -1 equals I, that means that we're getting imaginary answers. Because y'all, if you can't do it in the real world, it's got to be imaginary. So watch what they do now. This square root of -4, they make this a square root of 4 times a square root of -1. So they break it into a 4 times a -1. Because now, what's the square root of 4? Well, the square root of 4 is a plus or minus 2. Now, I can't take the square root of -1, but guess what I'm going to replace it with? I'm going to replace it with that I. So y'all, if the number under the radical is negative, you're going to get imaginary numbers, okay? And that's what the I represents. So watch this. If I do a square root of -9, that's going to equal a plus or minus 3I. Y'all with me? Square root of -25, that's going to equal a plus or minus 5. There you go. So negatives under radicals basically turn into I, okay? And y'all, guess what? We have that over here. I got a plus or minus square root of -7. So over here, the exponent cancels a radical. You get your x. This will equal a plus or minus. So you still can't take the square root of 7. So you're going to bring down that square root of 7. But remember, we're breaking this into a square root of 7 times the square root of -1. And the square root of -1 makes that a I. Now, here's the thing on this. It might be easier if you do the I first and then the square root of 7 on that one. Because if you type this in MATLAB, when you put the 7, you got to arrow out of the radical before you put the I. So that's why I usually put them in front so that it don't get mistaken for being up under there, okay? So I square root of 7 and negative I square root of 7 would be your two answers. Well, ain't this one about to do the same? I got to get the x squared first by subtracting 9. So I'll bring down my x squared. And then 0 minus 9 gives me a -9. All right, square root this. So y'all, I got the left side. That radical is going to cancel that exponent, giving me an x. And I know this will be a plus or minus. So what is the square root of -9?
3.
3. Give me a little bit more. Because y'all, that's negative under there. So this, you can't do that with a 3 times 3 or a -3 times -3. So remember, since it's negative under the radical, this is a plus or minus 3I. Now watch this. We got a calculator, right? Let me show y'all a trick on that calculator. Let me clear all this out of my y equals and quit that screen. Oh, y'all hang on 1 second here. iPhone, who is this? I don't know, it might be Tricia because she's not showing up on my regular class. All right, so iPhone, answer who you are in a little bit. All right, y'all, so let me show you how to do the square root of a -9. We got a square root on the front, second square root, and then put in a -9 and hit enter. So you see how it's telling you get a non-real answer? Y'all watch this. I got a way to fix that. If you hit mode, and if we come down here to where it says real, if I arrow right on this A plus BI, that BI stuff means it'll let you do imaginary stuff with this. So watch this. Now when I do the second square root of a -9, it gives me the 3i stuff. Okay, Tricia, you're good. So if you set the mode, like I said, if you take the mode off of real and put it on A plus BI, the calculator will actually let you take square roots of negative numbers and it won't give you the error. Okay, the reason it's giving me the error up here in the real world is because in the real world, I can't take square roots of negative numbers, okay? All right, y'all, so that is the support, 5 of those. So I'm getting near the end of this lecture, so I'm not going to start 7-4. But y'all, I'm going to show you what formula we're playing with tomorrow, okay? So 7-4 is going to deal with the quadratic formula. So say you get one of those equations, those quadratic equations, and you can't factor it, or you don't know how to factor it, and you can't do the square root stuff. So to solve a form of the equation of this form, we use the quadratic formula, which says x will equal -b plus or minus square root b squared minus 4 times a times c, everything divided by 2 times a. And y'all, you get your numbers right here. A, B, and C will be in front of the x squared, the x, and the number at the end. If any of these are missing, you use a 0. Although A can't be 0, because you can't divide by 0. And if A was 0, you wouldn't even have a quadratic anyway, right? So B can be 0, C can be 0, A cannot equal 0. All right, so I'm just going to show you one example real quick. Remember that one I had? T squared minus 7t minus 8 equals 0. Y'all remember this one? We factored it a while ago, but I'm going to actually use the quadratic formula to solve it. So for me, there's no number here, so I would treat that like a 1. So A is 1, B would be the -7, C would be the -8. Now, I solved this by factoring earlier. I also showed you how you could graph and get the answers to this. But this quadratic formula works on any of these. Now, I probably wouldn't pick it to do this with, but I just want to show you how to actually work this. So x equals times my b, which is -7. So if your b is negative, you're multiplying by that negative in the formula. All right, plus or minus square root b squared. So that'll be -7 squared. You always want to put negative numbers in parentheses. Minus 4 times a, which is 1, and my c, which is -8. Y'all, all of that's over 2 times my a, which is 1. All right, y'all, so now it's just a lot of simplifying. Negative times a negative makes that a +7. Plus or minus. Under the square root, -7 times -7 is a +49. And y'all, you see all this stuff on the right side here? All of this stuff is being multiplied together. So that's like a -4 times 1, which is -4. -4 times -8 makes that a +32. On the bottom at the moment, 2 times 1 is 2. All right, so I'm going to bring down my 7 plus or minus my square root. So y'all, 49 and 32. Let's see, what's that giving me? 70 and 81. So that's an 81 all over my 2. Well, y'all, what's the square root of 81? Square root of 81 is going to be a plus or minus 9. And then that's all over 2. So now I use this to get my 2 answers. Y'all, to get the first answer, you use the plus sign in here. So that's going to be 7 plus 9 divided by 2. Okay, so you add the first time to get the answer. So 7 plus 9 is 16 over 2, which gives us 8. Well, you remember a while ago, we got -1 and 8 as our answers. Well, there's the 8. And when we graphed it, we seen that it was crossing at 8 on the x-axis. So there's your first answer. To get the second answer, you're going to use the minus. We're going to do 7 minus 9 divided by 2. Well, 7 minus 9 is a -2 divided by 2. And y'all, -1. So y'all, those are 2 answers we got a while ago when we factored it by, when we solved it by factoring. And then we seen that those were the places where it crossed on the x-axis. So here's what happens. Sometimes if you get imaginary answers, the quadratic formula will give me the imaginary answers. When we factor in the real world, we can't factor stuff and get those imaginary answers, okay? So factoring is limited on whether you can actually factor it or not. Y'all, this quadratic formula, it works 100% of the time. If you got an x squared term as your highest exponent, this works every time, okay? Now, I ain't gonna lie, it's a little more tedious than factoring was. And the trick on it is actually this part where you simplify these radicals. Sometimes they won't put perfect squares under there, and you got to learn how to simplify those. But y'all, we'll hit that tomorrow when we hit 7.4 and we start trying to simplify these radicals, okay? So I just wanted to give y'all a preview of what's coming tomorrow is this quadratic formula. And then another thing we'll do tomorrow and let's make this a right triangle. do y'all remember a formula that you could solve for the sides of these triangles? And this is a right 90-degree triangle. And y'all, this one we'll play with tomorrow also. It deals with, I'll say his name. How about Pythagoras? Have y'all heard of the Pythagorean theorem?
Yes.
Mm-hmm. And that one has a squared plus b squared equals c squared. So we'll play with this tomorrow actually too. This will hit us in 4.8. And then this quadratic formula is going to hit us in 7.4. Okay. So 4.8 is fun. It has two word problems that deal with finding the sides of one of these sides of the triangle. So it'll bring back memories. All right, y'all. So 7.1 was just 5 questions doing symmetry. 7.2 was just moving the graphs around a little bit. And then 7.4 support was solving equations, okay? That's getting you ready for my quadratic formula coming up. So, y'all listen, I sent the video going over test 1 review last night in an email, and I added bonus to it. It was just one problem. If you send me that answer, I'll add 5 points to your test 1. So that's almost half a letter grade on that test, okay? So if you made an 80, that'll turn it into an 85. If you make a 90, 95, and so on, okay? And it was just one little problem to do. All right, so Monica, I seen you access Blackboard, so good job.
I couldn't, the form that you said I needed to sign, I couldn't form, it wouldn't come up for me.
Oh, no. What you do when you're logged into Blackboard, go to the left side. I'll show you real quick. Let me share that screen. So you're talking about the course agreement.
Yes.
Okay, so let me move my chat out of the way. On the left side over here, it says MathLab student links.
Mhm.
You're going to click that.
Okay.
And then that's going to bring up all the MathLab stuff.
Okay.
Well, y'all are going to be more interested in the all assignments. That's where all your work is, okay? So y'all are going to click all assignments.
Okay.
Now, your first assignment is what says is the course agreement. That's the one that you got to do. Now watch, I'll show y'all what this is. This is not bad. So y'all can knock this out quick because it's not math related. It's just 5 questions over. I've read the syllabus, blah, blah, blah. Well, you only got one answer you can pick, and that's I understand. So you'll just go through that and click I understand on all those. And what's nice though, this actually counts as your first quiz grade. And you got to make 100 on this or you can't go on. So technically all y'all's quiz grades are starting out at 100 on this, okay? So once you do that, it'll actually let you go in and start doing your homework problems. So start 2-1 and 2-2 and so on, okay? But now remember the main thing I would do with you right now, for test 1, you got that review we did yesterday.
Mhm.
I would definitely do my 7-1, 7-2 stuff before I wasted a lot of time on the past stuff.
Okay.
And then when you get extra time, go back in and start doing 2-1, 2-2, and some of those, okay?
Okay.
You've seen a little bit of them on the review, so if I was you, I would just play with the review for the test 1 and then do the test 1, and then you can play with that homework later, okay?
Okay.
Yeah, the main thing is just getting that course agreement done so it puts you into my actual grade book. Cause right
Okay.
now you're just a ghost if you ain't never done it yet, so. All right, yeah, I was glad to see that. I was like, oh, okay, fine. They're a little slow at doing stuff sometimes.